Good morning, everyone. Welcome to the second session of Scilab. No dreams comes true unless and until you walk up and goes to walk. From the last session, you learned lots on Scilab. For advancement, you get in the session. Please, sir, for continue your invaluable lecture.
Thank you, Dr. Sarfaraz Ahmed. Good morning, all the participants to this faculty development program on scientific software. Myself, Dr. Biju Kumar Dutta, Associate Professor, Department of Mathematics, the Assam Kaziranga University. In previous lecture, we'll discuss various mathematical operations on the Scilab and how can you use the psi nodes. Without any further delay, let's start my second lecture. In last lecture, we just created this psi node, and here we have to show whether uh, this metric operation it will hold or not. We are just considering some random matrix. Um, A is a random matrix of size. A is a random matrix. Okay, wait. A is a random matrix of size 5 by 4. B is a random matrix of size uh, 4 by 3, and C is a random matrix at 3 by 2. After that, we just find it out its size, its product, and whether um, it will satisfy the associative property or not. Okay. Now, if you observe, if you observe in the psi node, okay, the file extension is .sci. Now, okay, now, okay. Again, next we discuss about the various flow control in Scilab. Some control statements are if, else if, then select, then for and while. These are a loop. Okay, looping. Suppose if you want to stop the looping, then you can use the command the break. Now the syntax of if. Now the left hand side I'll display this is your general syntax for the if. This is a condition statement, and if first you write it here, the expression this first you type here the expressions. Okay, here this is expression 1. If this expression 1, if it is satisfied, then it will execute this statement. Okay, suppose if you have more than one statement, that is expression, then the expression ith expression, if it is true, then it will execute this one. Otherwise, this is the case for otherwise case. Otherwise, it will execute it uh, executed this statement. Now you have to remember here this if statement, it will this condition statement, it will end. Okay, if you use this, okay, word. Okay, so this is the body of first expression 1, the ith expression, and else. Okay, then it will end with here. Suppose I'm consider uh, one quadratic equation. So this is a quadratic equation, general quadratic equation. We know the root of this quadratic equation, x equal to minus b plus minus root over b square minus 4ac divided by twice a. Depend on this term. Okay, so we can classify our root. Okay, first one, if b square minus 4ac equal to 0, so um, we we have to print, suppose we have to print it is a real and equal roots. Okay, now if b square minus 4ac, if it is a positive, then it's a real and unequal root, and b square minus 4ac, if it is less than 0, then we will get the complex root. Suppose we have to write a coding, okay, for this example. Now I'm just going to my side note. In side note, I just use this one. So if this is a statement, if this is true, then I'll display this part. That means it has a real and equal root, and if not satisfied, again you just say whether if it is positive or not. If this is positive, then it will display real unequal root. Otherwise, it will display the complex root. Okay. Now this one, okay, um, this one it will use for the comment. Okay. So this part is not executed. It is for our purpose. After that, I just save this coding, okay, and then press execute. Now I'm just assign, suppose a equal to 1, b equal to 2, and c equal to 1. So b square minus 4ac. So b square minus 4ac. So it will give you 0. Therefore, it will display equal root. Then if you notice in this console, then it will display it has roots are real and equal. Okay, so you can easily show it here. Okay, fine. Now if I change this value, like suppose I'm assuming, suppose a is now um, suppose 3, and suppose c is suppose 2 or minus 2. Now if I again save and execute this one, so again we are notice that the b square minus 4ac, so which is a positive number, so it will display real equal root. So this part it will executed. Now if I consider this one is a positive one, okay, positive number, so if I execute, save and execute, it will display the complex root. So these are some uh, initialization of a, b, c. Or you can input, okay, you can ask okay, you can the pop-up on menu, just use a command input, okay, and then it will automatically store this value here. Now if you notice in earlier console, okay, so history is there. Now how can you clear this console? So for you can use clc clear, it kill all the variables, okay, and execute. Okay. Now last, this one is a display because it will execute the last statement. Okay, fine. So this is your if a conditional statement. Next, the select statement. Now how can you okay, so this is a basic syntax for statement. First, so you need one variable. So depend on the value of this variable, okay, it will execute this instruction. Suppose if it is true, then it will execute this instruction. And similarly, suppose if you define some cases, n cases, okay, so if this one is true, then it will execute the nth instruction. Now similarly, you can input, okay, some value, okay, like 0 1 2, okay, then if the if some of them, if they are true, then okay, so this, okay, the instruction C, it will execute it. Otherwise you can use else command for executing this. Now the select statement, it will close with the end. Okay, suppose I'm consider one example. Using the select statement, set the value of x depend on the value of x. A defined message is displayed like x equal to 1, x equal to 2, x dot dot x is 4. Okay, otherwise display x is not in between 1 to 4. Now I'm again go to my side note. Wait. Side note. Okay. Now if you notice, okay, so I'll display here. Okay, so this is a second example by using select statement. Suppose I'm just define this variable, suppose x equal to 10. Now the select, so x is a variable. Since now first case, if this x is 1, it will display, okay, I'm using the command display x is 1, x is 2, x is 3, x equal to x is 4. Otherwise, if it is not satisfied, then it will display this part. Okay, if you if I save and run, okay, if I execute it, then you notice that, so since x equal to 10, so it will execute the last, okay, statement. Now similarly, if I change this value like 2, okay, and 7 execute, then it will display x is 2. Okay, next 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 looping. Okay, so the how can you, the syntax for looping. So first, some expression must be there, variable, and then some expression is there, and we'll give some instruction. If until and unless this expression is true, then it will execute these instructions, instruction 1 to instruction n. Okay, now in another way, someone can use here, okay, do command, but both are the similar. Okay, now the for looping, it will end, okay, in earlier similar to your earlier statements, every statement it will end with end. Suppose I want to generate the Fibonacci number, and everyone know about the Fibonacci number. So first is 0 and 1, so actually these are some initial. Now sum of these two, it is your 1, okay, then 1 plus 1, it will 2, 1 plus 2 is 3, again 2 plus 3 is 5. Okay, so it will generate in this way. That means if you want to find this position, then you have to add, okay, the previous two number. Okay, so this is your Fibonacci number. That means, so Fibonacci n place, it can be find, okay, it is sum of the previous two number. Okay, and this, okay, so I'm using FIB, so it is a FIB, so it is a iterative. Okay. Now I'm again go to my sine node. Go to my sine node. Now, so, here I'm using one. I'm using here FIBO. So this is nothing but this is a variable. First, N1, it is the in sine node. In sine node, okay, wait. In sine node, if you notice here, the first line, it is the comment. This is also the comment. Suppose I'm consider n terms is equal to 10. That means how many number of terms you have to display the Fibonacci number. So as discussed earlier slide, so first two number, okay, then 0 and 1, first we have to initialize, okay, then use fib and, okay, use this one as an iteration. So I'm just consider FIB. This one is a array. The first element of this array is 0 and this is 1. Okay, without using array, you can display, but I'm consider this array. Okay, now this is a for loop. Now first we start is for n equal to 3 to n terms. Okay, n terms. Then I'm just writing here this iteration. It will calculate until and unless this value of n, it is equal to n terms. After that, it will store in the variable fib, and then I just display fib, okay, FIB variable at once. So if you press, okay, if you F7 executed, then it will display all the numbers. Now someone can count the numbers, and if you notice that there is 11. Okay, if you want to decrease it, then you can simply write -1 here. Okay, then 7 execute. Okay, now next, suppose if you increase this one, like if you generate Fibonacci number to 20, so simply you have to change this one, and it will display first 20, 21 Fibonacci number. Okay, next, next it is a while. So while can be written in various way. This is a while, then expression, then instruction. After that, while is end with this n word. Similarly, while someone can write do here, okay, expression, do, instruction, and So while expression, then instruction, both are same. Suppose I want to generate the same. Um, Suppose I want to generate the Fibonacci number by using a while loop. Then how can I generate it? Okay, wait. Uh, now in side note, the same, okay, similar statement are there. So only difference is that instead of this one, if you write this is your term, suppose trn, and I'm writing here n equal to, okay. Now first two we have to initialize fib. Now same, okay, similar argument, we have to write it down here. Now if you write this is n, then I have to write it here, all I, it is change this to n. Since I am familiar with I when I'm using uh, the looping, so that's why I'm writing here n. Okay, I'll just explain. First, first it will execute it, while it will execute it this statement. So this is a expression. If this expression is true, then it will execute its body. Okay, it will execute its body. Now when you using the while, okay, this variable n you have to increment. Okay, so n equal to n plus 1, increment by 1. Then first, if you look at this variable, it will enter 2, and since we have to our number of term is 10, so 2 is less than 10, so this expression is true, that's why it is executed, this one. Now if you not written this one, so this while loop it will execute it infinitely many times. Okay, now next line, okay, so that's why we have to increment this one, so n equal to n plus 1. Okay, now after that we have to display fib. Okay, save and execute. Okay, so before this one I'm adding here, it will clear. Okay, clear the console, then clear, so kill all the variables, so save and execute, so it will display first 10 Fibonacci number. Okay, so this is a while. Now next part, how can you define the function in Scilab? The general syntax for defining the function, it is your, first you write the function, and this is your some arguments. Okay, it may be singular argument, or it may be some array or something. Okay, now the after that you write the function name and its arguments, like this may be like y equal to, we are writing y equal to f of x, something like that. Now here, how can you define this function? You have to write the statement here. So every function, okay, it will end with n function statement. Okay, this is one way. Other there is another way. If you use def command for defining the function, but I'm using here only the function. Okay, come on. Suppose I have to write one function which will generate my Fibonacci number. Okay, so this is my Fibonacci number. Now how can you write this function? I just display in my side note. Wait. Now so this is my function. I'm just consider this is your y is equal to fib. Now this fib, it is not a variable, it is a function name. You have to remember it. This is a function name. Okay, now I'm to initialize like earlier one, y1 equal to 0, y2 equal to 1. Okay, and then I executed this. Okay, executed through by using this for loop. Okay, now without this one you can write the recursion. Okay, if you are familiar with the function, later on you have to modify this coding later on. Okay, now here after calculating all this thing, it will return y. Okay, now how can you call this fib? Suppose I'm putting here n equal to 10, or simply without this one, suppose I have to display, suppose first 10 Fibonacci number, simply you have to display fib 10, so it will display. Okay, actually it will display 11. Okay, now if you modify this one like 15, so it will display first 15 Fibonacci number. Okay, so this way you can define lot of functions. Okay, we will discuss this thing later on. Now wait. Now next part is plotting in Scilab. So the plotting in Scilab, you can use 2D plot, 3D plot, a lot of that means okay, or you can do in Synode. In Synode, okay, wait. In Synode, if you notice here, the first line, it is the comment. This is also the comment. Suppose I'm consider n terms is equal to 10. That means how many number of terms you have to display the Fibonacci number. So as discussed earlier slide, so first two number, okay, then 0 and 1, first we have to initialize. Okay, then use fib and okay, use this one as an iteration. So I'm just consider fib, this one is a array. The first element of this array is 0 and this is 1. Okay, without using array you can display, but I'm consider this array. Okay, now this is a for loop. Now first start is for n equal to 3 to n terms. Okay, n terms. Then I'm just writing here this iteration. It will calculate until and unless this value of n, it is equal to n terms. After that it will store in the variable fib, and then I just display fib, okay, fib variable at once. So if you press, okay, if you S7 executed, then it will display all the numbers. Now someone can count the numbers, and if you notice that there is 11, okay, if you want to decrease it, then you can simply write -1 here, okay, then 7 execute, okay. Now next, suppose if you increase this one, like if you generate Fibonacci number to 20, so simply you have to change this one, and it will display first 20, 21 Fibonacci number. Okay. Next, next it is a while. So while can be written in various way. This is a while, then expression, then instruction. After that, while is end with this n word. Similarly, while someone can write do here, okay, expression, do, instruction, and so while, expression, then instruction, both are same. Suppose I want to generate the same um, suppose I want to generate the Fibonacci number by using a while loop. Then how can I generate it? Okay, wait. Now in side note, the same, okay, similar statement are there. So only difference is that instead of this one, if you write this is your term, suppose trm, and I'm writing here and okay. Now first two, we have to initialize fib. Now same, okay, similar argument, we have to write it down here. Now if you write this is n, then I have to write it here, all I, it is changes to n. Since I am familiar with I when I'm using uh, the looping, so that's why I'm writing here. Okay, I'll just explain. First, first it will execute it, while it will execute it this statement. So this is a expression. If this expression is true, then it will execute its body. Okay, it will execute its body. Now when you using the while, okay, this variable n you have to increment, okay, so n equal to n plus 1, increment by 1. Then first, if you look at this variable, it will enter 2, and since we have to our number of term is 10, so 2 is less than 10, so this expression is true, that's why it is executed this one. Now if you not written this one, so this while loop it will execute it infinitely many times, okay. Now next line, okay, so that's why we have to increment this one, so n equal to n plus 1, okay. Now after that we have to display fib, okay, 7 execute. Okay, so before this one I'm adding here, it will clear, okay, clear the console, then clear, so kill all the variables, So 7 execute, so it will display first 10 Fibonacci number. Okay, so this is a while. Now next part, how can you define the function in Scilab? The general syntax for defining the function, it is your first you write the function, and this is your some arguments. Okay, it may be singular argument, or it may be some array or something. Okay, now the after that you write the function name and its arguments, like this may be like y equal to, we are writing y equal to f of x, something like that. Now here, how can you define this function? You have to write the statement here. So every function, okay, it will end with n function statement. Okay, this is one way. Other in there is another way. If you use def command for defining the function, but I'm using here only the function. Okay, yeah. Suppose I have to write one function which will generate the, my Fibonacci number. Okay, so this is my Fibonacci number. Now how can you write this this function? I just display in my side note. Wait. Now so this is my function. I'm just consider this is your y is equal to fib. Now this fib, it is not a variable, it is a function name. You have to remember this is a function name. Okay, now I'm to initialize like earlier one, y1 equal to 0, y2 equal to 1. Okay, and then I executed this. Okay, executed through by using this for loop. Okay, now without this one you can write the recursion. Okay, if you are familiar with the function, later on you have to modify this coding later on. Okay, now here after calculating all this thing, it will return y. Okay, now how can you call this fib? Suppose I'm putting here n equal to 10, or simply without this one, suppose I have to display, suppose first 10 Fibonacci number, simply you have to display fib 10, so it will display. Okay, actually it will display 11. Okay, now if you modify this one like 15, so it will display first 15 Fibonacci number. Okay, so this way you can define lot of functions. Okay, we will discuss this thing later on. Now wait. Now plotting in Scilab. We'll explore the plotting in Scilab. Now a powerful tool for numerical computation. The Scilab provide various functions for creating 2D and 3D plots. and you can also create, that means find pie diagram, bar diagram, etc. We'll cover here the basic starting with the plot for simple 2D graphs. Later we have to use the plot 3D for plotting 3D surface, and the customization of plotting with a title, label, and legends, etc. Now we just go to my screen. Okay, this is my screen. First I okay here. Now first you can plot in the console, or you can plotting in your sign note also. Okay, so suppose I just create here, consider one new sign note. Suppose okay, first I'm using the plot command. Now first one, the plot y or plot xy or plot function, so some list of function and its parameter, or plot x comma polynomial, plot x comma rational. Okay, so these are some syntax for plotting. Suppose I want to plot the sine x curve in between 0 to twice pi. Okay, in between 0 to twice pi. So in sine note, okay, I'm open this sine note. First plot, this is a comment. Now first x, okay, so x is equal to 0 to twice pi. Okay, suppose you okay, now next part, what you do, simply you have to define y is equal to sine then x, and use the plot then x comma y. First we will save. Suppose plot, suppose this is my example, suppose okay, plot. Now execute. Okay, sorry, undefined variable, oh sorry, I have mistake, it is your into, so it is a percentage pi, so it is plot. Now you notice here this this plotting. So first look this increment, okay, in between 0 to twice pi, the value of x, it will increment it by 1. Okay, next 1 1 1. Okay, suppose I'll do smooth this graph. How can I do it? So for this one I just increment, I write it here 0 0.1, then use column, so it is increment by a 0.1. Okay, now you again you notice that the previous, okay, now my curve is smooth, okay, but the previous plot is there. Now how can you clear? So clear CLF, and if you use a close, then previous window is closed, or you can use the command for clear. Okay, it will kill all the variable clear button. So this is your, okay. Suppose you want to add the sine 2x curve here or sine 3x curve here. Okay, so simply suppose this is my y1, suppose y2 is your, suppose sine 2 into x. Okay, and I am to display both the curve at once, so x comma y2. If you save and execute, so first one is, okay, this one is black color, it is your sine 2x, and this blue color, it is a sine curve. Okay, in another way, okay, in another way you can write this thing, okay, instead of this, if you write this thing directly, like it is your sine x comma, okay, another way, that means first I'm writing here y1 and y2 comma y2. Okay, so it will display one error. Okay, so it will display a wrong size of input argument. Okay, so how can you rectify this error? Simply you have to use here transpose. Okay, so dimension of this one, it will say. Okay, so this is another way. So, suppose I am to, okay, instead of this one, again I can modify this, like it is your sin x sine 2 into x comma sine 3 into x. So this is, okay. Now you can customize this, you can customize this plot. Okay, now next suppose I want to write my title, then I can write the x level, y level, region, etc. Okay, next we have to, so how can you write x level, y level? Next, suppose I write here, okay, I display here x level, y level, and the title. So these are some a command here for displaying the x level. Suppose in x direction I have to display x. Now in y, suppose I have to display about sine, you write sine x. Okay, I have to display sine x, the sine 2x, and then suppose sine 3, then x. Okay, in title I'm writing here sine curves. 7 execute. So you notice that here this is your, in x you are finding here this x level, okay, and this is a y level, and this is a sine curve. Now you can change by double clicking this title. Okay, double clicking this one, and you can enter here as per your requirement. Okay, sine curve, suppose sine plots. Okay, so it is depend on it. Similarly, you can change this a title later. Okay, suppose you want to import this plot. Okay, so simply go to file, then press export to, then here you can save it by PNG image or JPG image or a different EPS form or PS form or PDF image. Lot of options are there. Okay, suppose I want to save this one in JPG format, so simply give here the file name and then here. Okay. And if you go here, so this one just stop. In this way you can export this graph. Next, you notice that here it is difficult here. Which one is your sin x curve, sin 2x curve, or sin 3x curve? Now you can use the Legend command. Okay, so you can use the Legend command. So you can write next about the Legend. Now simply you have to write one string. So it is a sin x, comma, sin 2x, comma, sin 3x. Bracket is closed here, and then string is closed. Okay, then 7 execute. Okay, I forgot to write here. It is this one. So blue is for the sine, and green is for sin 2x, and red is for sin 3x. In this way we have to write that lesson. Okay. Now again, in earlier example, if you want to plot the Fibonacci number, okay, so if you want to plot the Fibonacci number, so this is a Fibonacci function. Okay, I'm creating this Fibonacci sequence. Okay, so here I'm just only change it. Okay, I'm only store in Fibonacci sequence variable, it is stored, and then I just plot. Okay, if I plot it, then we will get this. So this is your Fibonacci sequence graph. Okay, now this minus arrow, that means it is for dash. Okay, dash is line, R is for red, and O is for that point. Okay, so if you want to plot the points, then you can use in this way, or if you want green, then so this is green. Now more help. Okay, then how can you get the help? Now just simply right click here, and then you can find here help on plot, or here you have to type help plot. Okay, a lot of options are there. So suppose I'll show this one, right click, help plot. So first one, it is syntax. Then arguments, how can you pass the arguments, okay, different type of argument. Then um, descriptions, some remarks, and then some example. Okay, so here you can draw some subplots at once. So these are some example. Okay, you can run this example directly by hitting this play button, so it will directly execute it in Scilab. Okay, and you notice here, you if you notice here, if you notice here, this is your, okay, this will execute here directly. Or if you want to copy, wait, not this one. Oh. So this is for Synode. Okay, so it will directly, you are getting the code here, you can modify your as per your requirement. Okay, so I don't need this one. Similarly, this is your another example, this one is another one, then this is another example. Okay, lot of examples are there. Now if you are if you know the latex, then you can directly display the legend in the form of the latex. Okay, so these are some example are given here. Okay, so r equal to this one. Okay, so r is a, actually r is a polynomial. Now you have to display this polynomial in form of a latex. So this is the command. So legend pretty print, then r latex, and okay, so these are display, how can you display the latex command. So look, this is a display. Okay, so these are the polynomial. And if you want to draw in dotted form, so lot of example are there, go through this help file. Okay, lot of example are there. Similarly, 2D plot, it is there. So for 2D plot you can get lot of actually plot and 2D plot are more or less same, but you can get more options. Okay, then plot command. So these are some examples. Okay, next, plotting in Scilab. In Synode, I'm writing here one coding. First, I just consider x equal to linspace minus 5 to 5 and 100. This linspace command, actually it will create 100 points in between minus 5 to 5. And I'm consider y equal to linspace of minus 5 to 5 to 100. Now, after that, I just create one mesh grid because it's a 3D plot. So that's why I just create one matrices, or I say it is a 3D array which is replicated from our small x and small y. Now I'm consider z equal to x square plus y square, and I'm doing here element by element square. After that, I've used the command plot 3D x, y, z, and I label some uh, x level, y level, z level, and the title I just given here. If I run this, then we'll get one 3D plot here. Now next part, how can you rotate? Okay, you can rotate this 3D plot by press the right click, okay, and drag it. Okay, so this is your 3D, this is your 3D plot. Okay, this one. is a 3D plot. Now you can also change X label or Y label. Simply you right click and label are there, so you can modify your label from from this right from this menu. Okay. Now next, if I just change to this one, to sine and cosine function, and if I plot, so we are getting this type of figure. Okay, this type of graph. Now if you now if I change this one to, suppose this is a 200, and suppose this is a 200, and again compile, then you notice that we are creating 200 point in between minus 2 pi to pi. Okay, similarly y, then right click and drag it. So this is a graph. Okay, this is a another graph. Now next, a lot of options are there. You can go through these options. Okay, you can go through these options. Now next, the polar plot. Okay, how can you draw a polar plot? I just consider here, this is your, actually this one is a coordinate equation. I'm just consider, first I'm defining what is my r, and I'm consider here theta is from 0 to twice pi, and I'm consider 100 points, okay, in between them. Now r equal to 1 plus cos theta. So use the polar plot command and use some labels and run it. So this is one example for polar plot. Okay. Now next suppose you want to draw the pie diagram. First you feed some data and then add some labels, then simply uh, pass this data through this pie and then give a label here. Okay, so this is a pie diagram, and you notice that it is 360, and if I sum it up, then it is 100. So it is calculate this thing automatically, and if you want, then you can export. Okay, you can import this file here. Now next okay, next one, how can I draw the bar diagram? Suppose I'm just consider three groups: group 1, group 2, group 3. They will contain three elements. Okay, and I just give the position where I have to plot this one, then bar, then position, and I'm writing here the group 1. Since group 1 is a row vector, so I'm just writing here the, it is your, I make it a column vectors. Okay, so that's why it is a transpose, it is used, and then execute. So this is your, okay, this figure is your group bar plot. Okay, so these are some example for plotting. Okay, you can go through the help file. Okay, so a lot of things are there. Again, in Scilab, you have to find here one icon. Okay, so in earlier version this icon is not there, but if you go through here, then you have to find it out. Lot of example. Go to graphics, 2D and 3D plot. Okay, so these are some different type of plot: contour plot, Okay, so some examples are there. These are, okay, these are some contour plot. So these are the example. Okay, so similarly you can find here gray plot. This is, so these are some given examples. Okay, now lot of basic function animation, it is there. You can make an animation by yourself. Now this is a Lorentz curve. So these are some examples. Next we'll learn how to solve ODE in Scilab. We are considering one initial value problem. So dy by dx equal to f of xy. So this is my initial value problem, and this is the initial condition. Now simplest way to solve the ODE is the command ODE. First we have to pass x naught. Okay, first we pass the value y naught, x naught, x and f. Suppose we are considering one initial value problem. First we have to identify what is my f of xy. If you compare with the general case, so my f of xy is sin x plus cos of x. First we define our function here by using the function, and I'm writing here dy dx. You can use, instead of dy with dx, you can any variable, and then dy dx is equal to, it is your sin x plus cos of x, then end the function and function, then pass these things in command ODE. Okay, and so we have to define some ranges. So it is your y naught value. Y naught is nothing but is a pi. It is your 1 and it x and then function, and you store this value another variable y and display it. Okay, if you want, then you can display. Next, if you have this type of second order ODE, then how can you solve this one? For solving of this, so suppose we are consider dy dx is equal to suppose z, then this differential equation is transformed to dz dx minus 6z plus 5 of y is equal to 3 e to the power 2x. So this implies dz dx is equal to 3 e to the power 2x plus 6z, then this is a minus 5 of y. Now we have to write this one inside the definition of the function. I'll show you later. Again, this is your initial condition. Now how this initial condition, I just pass through one column matrix. Okay, so if this one is a vector, if this one is a column vector, so the variable we have to y and z, it must be, we have to pass these two variable in an array. Okay, I'll show you. also this one. First, we have to define, like earlier one, first we have to define our function. So this is your function dy by dx equal to f of x. Then first we have to initialize. This is the first problem. So y0 value is 1 and y0 is pi. Suppose I have to calculate this value from pi to twice pi. Okay, and the increment is, I'm just consider 0.1. Since OD, okay, I just use this one, and then after that we have to plot the value. That's why I just consider some points. Okay, and then pass this thing in OD. After this OD, it will calculate the value and store in the variable y. Then I just plot this variable. If I run this one, so we will get this one, the solution. Now again, if I increase this value to 5 pi, then I'll get this. So this is the solution curve. Again, the second one, if you look here, the second differential equation, first we have to write the z. Okay, I just variable z I have to retain here is y2. Again, y1 is nothing but the variable y. Okay, now first I define the function in similar manner. Then I just define one initial value of y, it is 2, 3. Then I just plot this figure in between 0 and 1, and similar way I have to write on the plot command, and I display the first value. Okay, so that's why I'm just consider only y1, because the z1, okay, because y2 is nothing but it is a dy by dx, it is not a solution. The solution is in y. That's why I just plot I just pass here y1 only. Then so this is the solution curve. Next, in next part it is an integration in Scilab. Suppose I want to integrate on definite integral, find the value of this definite integral a to b f of x dx. So for finding of this one, integrate this one numerically, I can use the simple command int z a b and f. Now if if I consider z2 f of z dz, so this one is a complex integration. So for complex integration, I can use the command intc, then similar argument we can pass. Now instead of this intz, someone can use integrate the command. Okay, then the function, the variable, then ab, you can pass this one. Okay, so also in the side note how to integrate it. Suppose I just define, okay, I just copied this part from here. Then first I just consider y is equal to f of x. Suppose y is a function of 1 divided by 1 plus x square plus 1 plus x square. Now simple, you use integrate command int tz, then first pass lower value, lower limit 0, upper limit 1, and then pass the function. Okay, pass the function and then display I. Save, suppose intz, and run, then go to, so this is the value, so this is the value. Now if it says this one limit is like, if I change to 10, so I can run, so this is the value. Okay, so I can write here the value, comma. So this is nothing but it's a string. So okay, now how can you solve the Cauchy integral? I just modify here. Suppose this is my function z. I just define the function z to the power and then some complex number 4 plus 3 into percentage I. Then I'm using here intc, then first 1 plus percentage I, and then 10 plus 2 into percentage I integrated. So this is the value of complex integration. In this way we can do a lot more. Now okay, now in the application menu, you have, if you notice here, there is a module, it is known as atom. If I press down this atom, then you have to find a lot of module they are built. Okay, so there audio module, lot of things are there. So as per your requirement, you can download this module, you can install this module. Okay, and then you can do your, okay, suppose I'm just consider, I just show you, so root finding. Okay, root finding, you can install this module. So it is now it is finished. So then you notice here this one. Okay, so you just go to the help file. Okay, you just go to this root finding help file, and then so here help, then root finder. So this help file is there, so some examples are there, go through it. Okay, go through it. So as per your requirement, you can install the module atoms. Okay, under atoms you have to find it out. So again, main category, image processing modules are there. These are the image processing modules. The graphics are there. Now signal processing, lot of things are there. Now again, um, if you go to so, okay, atom web page, okay, if you go to in your atom home page, so you have to find out the new modules if they are available, or you can download this module, or okay, suppose image processing design toolbox. So this image processing design toolbox, it is only for Macintosh and Windows system. It is not for Linux. Okay, so before installation that module, you have to you have to go through here. You have to find a lot more. Okay, today I have finished my lecture here. We'll see you at doubt clearing session.
Thank you, sir, for your mesmerizing and wonderful presentation. I think it helped to every aspirant who are attending fabulous scientific language FDP organized by Department of Mathematics, the Assam Kaziranga University.